Okay. Thanks for coming for this talk. Today's topic is integration and end-to-end testing with test containers, and my name is Nikolay. So I'm doing Go development at Zalando in Helsinki. Originally, I'm from Russia, from St. Petersburg, but before switching to Go, I've did about 6 years of Java development at different companies. So that's where I get to know test containers, and I really love this library, and I hope you also enjoy this library. So let's see a short video why we need integration testing at all. This is like the case, like you can find a bunch of videos or images at the internet which says like 2 unit tests pass, but 0 integration test, and then you get everything messed up. So in this sense, integration tests are important to have also. But we should keep in mind about the trade-offs we get when we choose to use unit test, integration test, or end-to-end test. So this is how it should look like in an ideal system. The number of we get more unit tests, we get a little bit less integration tests, and then we have a small number of end-to-end tests. And since we go higher this pyramid, then test time increases dramatically. Also does the test scope. So this is a very basic scenario. We have some service, and we have some database. So in this example, we have Spring Boot and Postgres database. So how would be able to test this kind of interaction with our database? So if we step back and think about the history, how it was done before. So it was done with in-memory mocking. I think many of you remember H2 database that people used to emulate Postgres or MySQL, MySQL. But then also for integration testing, we can use local database. We can run that at local machine or at CI machine. Then there was a variant introduced. Fairly speaking, I skipped this step myself. I never used variant. But then this came Docker, and you can use Docker and Docker Compose. So you can have a shell script and run Docker run, and write Docker run. Then you will get some database running. And the next step is Docker API, and what we're going to talk today is about, so a test containers library will be based on Docker API, so it will be more flexible to use. So what kind of advantages we get when we use Docker? We start some database for integration testing in Docker. So first of all, we get 100% compatible databases. So instead of using some mocked emulation like H2 database, we get a real database. And for our integration test, we can use even the same version as we use for production, so to be 100% safe.
Can I interrupt?
Yes.
Is anyone with a car in the parking lot push 10 TPK? We blocked someone. Sorry for that.
Okay. Yeah. So also then when we started a database for our integration test from Docker, we know about that state. So it will be empty or some known state if we apply some initialization script on top of that. So what are our options? How can we start Docker container and use that for integration test? Actually, there are many options. You can have a shell script, you can have a Maven plugin, you can use Docker Compose, Docker API, or if you really want to overkill, you can start a Kubernetes or Minikube cluster just to run a single container for integration test. So let's see some examples. This is I copy-pasted from some real project. Then what we actually want to do is just to run Postgres, which is somewhere this line in the middle. But then people realize, okay, it's not very convenient. If I test it locally, then that container is not being queued. Next time I run the test, I have some data there, or like I cannot run the same script again, so because it will be the port conflict. And here we actually have at the host machine we have a fixed port, so if you run it again, you'll get the port conflict. And then people start to reinvent the view and add more and more shell commands to overcome those problems. They use these shell scripts. Also, as you can notice, we have hard-coded sleeping timeout, because we don't know then the containers actually, like the Postgres inside container will be ready, and at which moment we can actually connect to that one and use it. So another option would be Maven plugin. I used it once. It was a bad experience. It was very difficult to configure XML, and with, for example, this plugin, you can bind to Maven phases, and in phase pre-integration test, you will start the container. In post-integration test, you will stop the container. So that's feasible to use, but it wasn't very convenient from developer perspective. Okay, another option would be Docker Compose. So still here, we can see that we get fixed ports at the local machine or CI machine. So it basically means we cannot run multiple builds on the same machine at the same time, because otherwise you will get port conflict. And also, we don't get this kind of our test lifecycle being bound to Docker Compose lifecycle. So those containers will be still up and running even our test is finished. So we need to take additional measures to prevent that. Okay, now we are going to Docker API. So this is a Docker daemon which runs at the local machine or at CI machine. And actually, the next layer, it has REST API, which we can use. But I think most people, they just use Docker commands like Docker run or Docker stop, which actually use the API. But the idea of test containers, if we use the REST API directly, then we are much more flexible on that. So here comes test containers library. So what is actually test containers? Test containers is a library which wraps Docker Java. A library, it's a community library, not provided by Docker itself, but it's developed by community. And that's a library which allows you to interact with Docker API from Java. And then test containers provide you a lot of features which simplify your life as developers. It does Docker environment auto-discovery out of the box. You don't have to set any environment variable for that or any properties. It does host port randomization out of the box. It cares about shutting down the containers after your test has finished. And it provides you a bunch of readiness waiting strategies out of the box. So if you are just starting to use test containers, then it's very simple as this one. There is a core class which is called generic container. There you just provide your image and the tag, and then you say which port out of container you want to expose, and basically you are done. You will get that container being started from your test. And the cool feature that the life cycle of this container would be bound to your test life cycle. Okay, and the next line is about Postgres container because this library is not, it's kind of already mature library, and it provides you out of the box several databases which are more convenient to use than generic container, which are already pre-configured for you. So Docker environment discovery. So if you run Docker compose, if you run test containers, if you start the container, then it automatically detects the Docker environment. You don't have to do anything about that. So for host port randomization, that's a really cool feature, I think, for test containers because it prevents port conflicts. You don't have to care to shut down like old containers, or like you can run multiple parallel builds at the same machine or same CI machine, and they will not fail because of port conflict, because at the host environment they will use different ports, but inside the Docker containers they will use the same port. And test containers provides you API to get the host port. So because it's random, you need the way how to get it. So it's provided by API. Okay, there is a feature which is called, does container cleanup. So how it does, then you start any container from your test. It will start a special container which is called Rike, and that container which will monitor the containers you have started from your test, and once your test is finished, it will start to kill your containers. So actually this MobiRike is quite a simple project. It's just one file written in Go, 150 lines, and it provides this kind of feature, and then it's used by test containers library. Okay, waiting strategies. So then you start something inside the container. You want to be sure at what moment you can actually connect to this container and start using that. So you can wait on the host port to be ready. Like if host port open, it's already enough for you maybe, then you can start using that container. You can wait for getting some HTTP response at the specific endpoint. You can wait for log message being printed inside that container. You can wait for Docker health check, or you can provide your custom waiting strategy, or you can combine several of those to satisfy your needs. So basically, this is a simple example. If you don't provide any waiting strategy, then by default you'll get host port waiting strategy, and it will wait for default of 60 seconds at the host environment for the port to be opened. If it's not open, then it will declare your build as failed and stop the build. So basically, this is how you do it. You create the container and you say wait for the strategy, but in this case, this line is optional because this is the default strategy itself. And what's important that the strategy is implemented in such way that it will wait for the host port to be open, like at the host environment. But in the recent versions of Mac, it's not enough, because then you start the Docker container, it immediately opens the host port. So to the Mac OS, it looks like the host port is open, but if you try to connect there, you will get a connection rejected or refused, because actually some service inside the Docker is not ready yet. So it's important to check from inside the container that another port, the mapped port, is also open. So test containers library does that for you also. Okay, and you can also wait not only for host port to be open. You can wait for some HTTP response. For example, in this code snippet, I showed that you can override the default timeout. You can wait for 2 minutes, say, and you can wait for a specific endpoint, which is like actuator health for Spring Boot, and you can wait for status code 200. You can even customize more. Okay, let's have a first demo. So in this demo, this is the most basic scenario. I will have a Spring Boot service, which I call user service, and I will have a Postgres database. And first we will see. Can you read this one, or we need to wait? Can you read this one? Should I increase the font?
You can go to view and presentation mode.
Yes, but I need the console also. So I think it was here. Is it better? Okay, so this is a very simple, just one file Spring Boot application. And I implement a REST controller. It has two methods. You can create a user and you can get the user. So to save the user to Postgres database, I use just plain JDBC template from Spring. So this here, this is the user request. You can, so this is the user domain object. So it has the name and email and ID. So then you try to create the user. You don't have to specify ID. So it will be generated, and then we save that user to Postgres database here, and then they return the ID. And then we get this user. We just select by ID. That's simple as it is. And I have this file initializes the table inside the Postgres where we save our users. Okay, so let's see how we can test our interaction with Postgres database. So this is gonna be Spring Boot test. What's important here is test containers annotation. This is out of the box integration of TestContainers and JUnit 5. So this annotation will actually scan for those containers, another annotation we have in our test file, and before the test it will start them. So those containers are ready. Then you run the test. So here I start the Postgres container. This is ready-made model provided, Postgres model provided by TestContainers. So what I need to do is I want to override, by default it's a different version of Postgres, so that's why I provided here the version I want, and I specify what the database name I want, what will be the username and the password. But now for Spring Boot application, actually to know where to connect, how to find out this container, there is a special mechanism how we supply those properties inside the Spring Boot. So we customize application context initializer, and then those properties they get out of Spring Boot container and supply them to our application. So, and then basically the test is simple, like you create a user, and then you get the user, and it goes through for Postgres, and all works fine. So let's give it a try. I run it in debug mode. So basically here we see the output I already showed. So let's go back to console. So basically TestContainers was able to find the Docker environment, and then it started the Rike, which will monitor our containers and kill them. Then we finish the test, then it actually creates the Postgres container, and because I already have it, I already have the image at my local machine, so it doesn't have to pull it, but actually the library also is able to pull it automatically. And then basically now I am inside the test. Let's see what kind of containers we get running. Okay, so basically so basically here we have two containers started by TestContainers library. It's Postgres and Trike. So it will monitor then the test is done. So, and here we see that at the host port, we get some random ports. So this is the port where the Postgres is, and we can actually, because we are stopped in debug mode, we can actually connect to this port and see what we get inside the database. So, okay, so this is one of the tests, and we already have some user being created inside the test. You can see that, you can check that it's already in our Docker. So yes, here is the test. It was that user Andrei created, and now what I'm trying to do, I will create the user who has different name but the same email, and because email is same, and we have that constraint inside. Here we have unique constraint that's supposed to be failed. So if I check this one, then it will. So is it? Yeah, okay. The test has finished. So we can actually run the normal test again, where we just create the user, and then we get the user and verify that the user has the same name as we expect. And then you can actually see that that's going to be quite fast. It didn't take that much time, and we had the test which is against the real database, the real Postgres. So we are testing that our app can interact successfully with Postgres. So let's go back to the slides. So let's do some recap. So as I showed you, TestContainers does out-of-the-box integration with JUnit 5, and that's provided by extension API, which is new API in JUnit 5. And if you are just a user, then for you it's enough to know that there is test containers annotation and there is container annotation. But this integration is completely optional. It doesn't force you to use only JUnit 5. It just like you don't have that magic with those annotations, and then you have to run your containers manually with generic container or Postgres container. You can use it with JUnit 4 and so on. And another recap is about test containers models. So the core class of test containers library is generic container, but those models, they are the wrappers on top of that class, and they're customized for specific databases. And basically what it does, it provides you some APIs, some setters to set some properties, and then those properties are being transformed to environment variables inside for your containers. So, for example, if you want to set the Postgres username, you can set that by using the API and not by providing the environment variable. Okay, let's talk a bit about JUnit 5 extensions. This is the new feature, or like reworked feature of JUnit 5. So basically, there are test execution phases, and at each phase, this is like extension point, and you can customize the behavior at this extension point. and how to provide extension logic. So basically, in this package, in JUnit 5 API extension package, there are a number of interfaces which you can implement. And so there you do that kind of extension logic. And then you create like that annotation. Then we've seen like test containers. Then you register that annotation with extends with annotation of JUnit 5. Okay, and for test containers models, it provides you out of the box 14 database models, including Postgres, Elasticsearch, and so on. There is mock server. So with mock server, you can mock some, like, for example, say you need to call external service, and that external service, which you are not out of control, you can mock with mock server, run that in container, and configure this behavior. There is out of the box local stack container there, which is mocked AWS, done by Atlassian company. Then there is Kafka, Pulsar, RabbitMQ, and ToxiProxy. ToxiProxy allows you to emulate unstable networks. So using this container, you can emulate how your app would behave if you put some instability in between your services, or in between your service of Postgres or Redis or any other. So basically, if you don't find something you need inside the models, you still can use generic container, customize that, run that, and test against that. Or you can create a pull request and that as one of the model for test containers. So let's have second demo. It's actually not a demo. It's more about going deep about JUnit 5 extension mechanism. So here is the test containers annotation. If we see under the hood, it uses that extends with, which comes from JUnit 5, and then this is the custom class extension which implements that one. So maybe now I can go to presentation mode. So basically, here you implement the extension, and it implements number of those interfaces which come with JUnit 5 extension. They look like this, like quite simple. Okay, and so before all callback, here we have implementation for before all. What actually are we doing here? We are finding all the kind of containers we have to run like before all the test starts. So then we go here. So basically here you can see this is that this is container class annotation, which we've seen. Like, so to have that integration with JUnit 5, we have to mark each our container with that annotation. So that's how it works. So yes, basically here is the test containers annotation, and here we got the container, test container being annotated with container. Okay, and the second part of this demo was about the models. Let's see what's under the hood of Postgres SQL container. So it extends JDBC database container, and then that extends generic container, and generic container is the core class of test containers library. And then what we can see here, it uses lock waiting strategy under the hood. So it basically waits for this line to appear in the lock of container, and only after that it declares like our container is ready to be used in test. And if we go here, we can actually see that those properties we customize, like database name or Postgres username or password, they're passed inside, they're configured for the container and passed as environment variables. But but we didn't have to care much about that because it's provided as API, so it's quite convenient to use. Okay, let's go next. Okay, I would like to show you another demo, but in this demo, instead of Postgres, we are going to use Redis. Redis is in-memory cache, in-memory key-value store. So here I introduce another service called item service, and basically the flow would be that you can create some item, but if you create an item, you have to specify to which user it should belong. Then item service would call user service and check if that user IDs exist at all. If it exists, it will take the information about the user and store it inside the Redis. And the items itself are going to be stored only in memory in concurrent cache map. So let's see how can we achieve this one. How can we test this kind of flow with Redis and test containers? So this is another. So this is another application. So this is item application. It's a bit more complex to use. I mean, it's a bit more code because there is another service involved. We are calling another service. We are calling Redis. So for Redis, I use the latest version of Lettuce driver. For Redis, there are two options. I choose that one, Lettuce. So what I'm doing here, it has that REST controller for Spring Boot application, and then here we have that Redis commands API to interact with Redis, and here we have REST template provided by Spring libraries to call another service. Then someone wants to create an item, and item has category, description, and user ID. What we do, first we get from the Redis if that user is already there. If it's not, then we are calling user service with REST template. So if we got if we don't get the response, like if we get like 444 error code, then we are throwing exception. But if it's okay, this user exists, then we are storing that to Redis here. And then we just store the item inside the item store, which is only in memory, and we return the newly created item ID. And then we get another endpoint to get the item, and then we serve the item. So the idea here that we serve not only the item, but the full description of the user. So for that purpose, we also query Redis again. Get the user, merge the result, and give the response, item response. It's like this. So it has here the full user description, ID, name, and email. So let's see how we can. How can we test this kind of interaction with Redis? And for user service, I'm going to mock that response with Spring mechanisms. So here we are only going to be testing interaction with Redis, but not very much with user service. So basically, it should look the same as the first our test. It's Spring Boot test. We have the test containers annotation, but now we don't use the model, ready-made model for Postgres, but we are using generic container. Because like Redis is so simple, so I think that's why they didn't create a specific model for that. This is the latest version, and we want to expose this port, which is inside container, and it will be mapped to some random port outside the container. We do the same thing by injecting those kind of properties they get from the Redis. So here we get. We need to know what's going to be the host port, so we use that from API. We provide it inside the test. So then we do some mocking for user service, and then it's quite simple. The test itself, we create the item, and then we basically get the item. So yeah, and we mock that user would be exist in that in that user service, but still our service has to interact with Redis, because that it gets the user ID first. It will check Redis. If it's not there, then it will call user service. Then it will store the user information inside the Redis. So let's run this in debug mode. Okay, okay, it's stopped in debug. 1, 2. Okay, I need terminal again to see what containers we got running. So as you can see, we get this Redis running, and again the try container to monitor the test and kill the containers. So we got this port like exposed to the host machine. We can connect to the Redis with Redis CLI to this port. So we are connected to this port. We can get all keys. Okay, by the way, don't use this Redis key star command in production if you run Redis in production, because it will, if you get millions of keys, it will give you all the keys. Like there are better commands like scan, but for test it's okay to use, because we have just a single item here. So I can get the key, and here there is some information which gets stored during the test, because it called our user service, the mocked service. It gave some user information, it was stored, and so on. So if we go back to debug, let's continue the test. Okay, the test is green, so it passed. If we go back here, and then because the test finished and all our containers should be killed now. So let's see. Yes, so now all containers are gone. And we have clean environment again. There are no like zombie containers in our machine. So all of those demo code you can access at this GitHub link. So okay, but basically we learned that we can test our service, and we can test our integration with Postgres or Redis or any kind of database, Kafka. But okay, what can we do more? Or what have we done more? Like, should we care about end-to-end testing? And okay, in some cases, yes, we need to test also not just the single service, but how our multiple services interact each other. And especially these days, then many companies running microservices and business flow, they're across multiple microservices, and we want to make sure that our business flows actually work, those flows which bring money to the company. So basically, how can we do that in end-to-end testing? But just we still have to keep in mind that then we go up the pyramid, then it becomes more expensive, more time consuming to run the test, and more difficult to develop that one. And another use case I find very useful to have integration tests, and then you want to introduce a new service, or you want to remove the legacy service. So it will kind of rearrange your flows, your business flows inside your microservice ecosystem. So yeah, but from the client perspective, you want to be sure that the client doesn't notice that, and something which was working before, it still works even though you change the new service. Of course, there are different approaches. Instead of end-to-end testing, you can use like canary deployment. There is another approach by Spring Boot. It's called contract testing. But here we will continue to talk about end-to-end testing. I should go to present. Okay. So basically, imagine you have this test environment cluster. You can either run it by Kubernetes, maybe by Spring Cloud. Doesn't really matter right now. And you have a couple of services, and they all doesn't have to be a Spring Boot. Some of them can be Go, maybe other one is just Scala. So why cannot we use like this kind of already somewhere deployed cluster, deploy our new application, new version of application, and test against this cluster? I mean, of course we can use that one, but there are certain obstacles and certain inconvenience we can face when we try to use this approach. And one of the problem is that actually you get like unexpected version of some dependency services. And for example, you deploy a new version of your service, you're testing against that one, but at the same time, some of your teammates deploy some your dependency from development branch to do some manual testing, for example. And then your test would fail and you don't know why, and you have to investigate. Or maybe you would depend on the service which is provided by another team, and it's even more difficult to reach the team than your teammate. So it happens that sometimes you need to ask them to stabilize their test environment, and it can take days, hours, or sometimes even days. Another problem that by testing against your test environment cluster is that you get some unexpected database states, because probably other people in your company, in your team, they use that for their own testing. For example, front-end developers, they might use that your cluster also to test their own stuff, and they might not be happy if you generate hundreds or thousands of the same items and not care to clear the data of them, or maybe they generate something which will affect your test. So I mean, yeah, we can use that one, but it has certain obstacles. So another approach would be to make this cluster on demand. So it will be empty state. It will have only services you need for your end-to-end test. And then you can actually use it locally, or the ACI machines do the same stuff. Start the cluster, run the test, and so on. But the problem here that it needs quite a lot of time to spin up a new cluster. If you're okay with that, then you can go for that also. So if you want this kind of approach, how can we actually do this? I think there are a couple of options. One of them is Minikube. So if you actually run in your cluster, if you're running your cluster in Kubernetes, then you already kind of know something with Kubernetes, and you might go with Kubernetes for your end-to-end test. So if you want also to be able to debug it locally, you can do that with Minikube. Another approach is very promising project called Kind. It's kind of runs the Kubernetes cluster inside the Docker container, and you can actually run this Docker container using TestContainers library. And another feature, another option is that these days Docker itself provides you ability to run Kubernetes locally at your environment. So that might be beneficial then you develop this kind of test. But I think Minikube is a bit problematic for CI because Minikube still requires some installation. So in CI machine, usually CI machine have like Docker prepared for you by infrastructure team, but here you would need to roll out Minikube. It would take some time, or you need to have a special image for that. I mean, machine image. This has to be deleted, this slide. So, okay, so basically, I think that it's not always that you need Kubernetes to run your end-to-end test. For example, you're not using Kubernetes at all in your production, maybe you use Spring Cloud, something else. So, and even though you use Kubernetes, it might be much easier to do locally if you want to have a cluster. You just start the containers, combine them into the same Docker network so they can discover each other. You can do that with test containers. So basically, Kubernetes is nice for production. It gives you like many features like auto-scaling, those service discovery and so on. But for test environment, I think you don't need most of them. You just need your services running in the same Docker network, and then you can actually already test it, unless you want to specifically test Kubernetes features or some manifests you have in your code base. So here, okay, I got 5 minutes, 10 minutes, okay, good. So here I would do, because we already know, we saw the integration test for user service, which uses Postgres, and item service, which uses Redis. So here I will introduce another service, which is Spring Cloud Netflix Eureka. Basically, this is very simple service discovery. I think these days many companies stop to use that one if they're ever using that and migrate to Kubernetes. But the idea here that so it doesn't have to be with Kubernetes. Like you can do those kind of tests even you're not running Kubernetes. So this is kind of setup we want to check. We want to spin up and then to run some tests. And then here are some aliases, Docker network aliases, which we can specify, and that's also supported by TestContainers library. So basically in our setup, so for user service to know how to find the Postgres, we will configure that it should call by Postgres alias inside the Docker network. And that's it. And the same goes for Redis. So item service will find the Redis because of this alias. But because in this test we would like to use Eureka, which is service discovery. So it means that then the item service calls user service. It will not call by Docker network alias, but it will get the information from the Eureka, because those two other applications at the startup time, they register at Eureka. They put API and port. So Eureka knows it's a service registry and it knows those aliases. So the item service will call not by Docker network alias, but by Eureka alias. So let's first have so here I prepared integration end-to-end test. So let's not see how it's implemented first, but let's have it running first and see how many containers and how much time it takes. Actually, it takes quite some time, usually at least 1 minute, because we are starting 5 services. Okay, what I want to show during the startup time. So basically, we got those containers being started one by one by TestContainers library. Yes, so all of them are ready now, and then we can proceed with our code, but let's go back to terminal. So let's see, because in this test I intentionally create a new Docker network and then share that Docker network among all containers. So this is the new network. We can see what's inside this network. Okay, there is a lot of output, but what's important here, we have some containers, and those containers, they're like our started containers. Should be 5 of them, maybe 6 is right. And then for this network, there is this annotation or test containers true, and it has also session ID. So we are sure that this network was created by our test suite. And then if we see our containers again, we can inspect Redis container. Yes, it gives a lot of output. And then we can, so yeah, here. So basically, I'm inspecting that container, and this comes from the network alias, which is Redis alias, and then inside the Docker network, those that item service would be able to find Redis container just by this alias. So okay, so here is our test. It's quite simple. That's a lot of code, but it's quite simple. We will first create the user. We will create the item with the specified with the same user, and then we will just get the item and check that they get the item back and they get the user back. So let's have it running. So yeah, so the test finished, the test has passed. So all our containers should be queued now. Okay, still there is strike. Okay, now it's gone, and we still get the clean environment and no resources are wasted. Okay, so maybe because we didn't go much into details about how we are doing that, actually one of the approach would be the same as we've seen for integration test. We just start the containers, but then actually it requires some kind of wiring between them. They have kind of to know about each other. We have to provide aliases in different places. So this is a bit different approach. It's also based on JUnit 5 extension, but those extensions are custom extensions, and they're implemented by me. So you have kind of declarative way of saying which services you want in your end-to-end test, and then they get started, and you decouple your test code from those services you want to run. Let's go back to the code and see a bit more of details how we are doing this one. I think I'm soon running out of time. So basically, let's see with Redis. So Redis is the JUnit 5 extension. It's implemented by this class, which implements before all callback. Basically, what I'm doing, I'm creating this Redis container, which extends generic container, and in before all I'm starting that, and after all I'm stopping that, even though that's optional because we have in Rike, which kills all the container. And then if we go to see more details about this Redis container, it just extends generic container. Then we provide the image name, we provide the port, and then this is network. We just create a single Docker network with TestContainers API and then provide it for each container. And then we give here the alias, and then we provide the host port strategy, which is also optional because this is default. So yeah, so this is quite simple. If we go for a more complicated case, like how we start our user service, then it has some image name which is already pre-built, which is yeah, it's already pre-built. Then it also exposes the port, uses the same network, uses different alias, and then we customize that to be able to find at startup. It needs to register to Eureka service, so we provide that by environment variables here. Then we provide the URL for Postgres by Postgres alias, which is alias inside Docker network, and yeah, and then we provide the username and password to access this Docker, this Postgres inside the Docker. So yeah, basically that's the approach I wanted to show you for end-to-end tests. So it's kind of decouples the startup of your environment and then the test. And then for test, you can use, you don't have, like in our test, basically we are doing that, we are using some HTTP client in here. We are doing some posts to endpoint. There are some more libraries which provide some kind of different API to do the testing, but I think TestContainers is very cool to provide you the way to start the environment. And I think we have to finish. So basically, I have just 3 slides left. So sometimes you need to expose. You need to expose the port from your host machine inside the Docker network. So normally it's not possible because your Docker network is kind of isolated. But if you really need that one, then TestContainers provide you this kind of option by specific API call. Also, okay. I need to finish now, so sometimes you need, your containers are expensive to start. So there is a new feature merged 5 days ago, which allows you to keep the containers which are expensive to start and reuse them. So that will help a lot in end-to-end testing, I think. So these are takeaways. It's really great library. I love it. It works on Mac, Linux, Windows, and so on. It's great for integration testing, and it can be used for end-to-end testing. And that's basically it. Thank you a lot.